please stop the video so that way you don't hear my answers. So the answer to the first question is a vertical stretch by a scale factor of 4. The answer to the second question is reflect over the x-axis and a vertical shrink by a scale factor of a half. The answer to question number 3 is a horizontal shrink by a scale factor of 1/3. The answer to question number 4 is a vertical stretch by a scale factor of 7, as well as a horizontal shift to the right by 2. The answer to question number 5 is a vertical stretch by a scale factor of 3. And the answer to the question number 6 is a horizontal shift to the left by pi over 2. The essential question for chapter or lesson 8.4: what are the characteristics of the graphs of the sine and cosine functions? The vocabulary words: the first one is amplitude, half the distance between the minimum and the maximum points. Periodic function is a function with a repeating pattern. A cycle is the shortest repeating portion of this pattern. A period is the horizontal length of a cycle. For sine of x and cosine of x, the period is 2 pi, which is an entire circle. A phase shift is a horizontal translation of a periodic function. And the midline, the equation y equals k, where k is the vertical shift up or down, y equals 0, the x-axis, if k is 0, and then there is no vertical shift. The core concept, characteristics of y equals sine of x and y equals cosine of x. The domain of each function is all real numbers. The range of each function, y is less than or equal to 1 and greater than or equal to -1. So the minimum value of each function is -1 and the maximum value is 1. It makes sense because if you are going around the unit circle, the highest number of all the trigonometric function values for sine and cosine is 1, and the lowest number is -1. The amplitude of the graph of each function is 1/2 of the difference of the maximum value and the minimum value. So if the maximum value is 1 and the minimum value is -1, it's half times 1 subtract -1, and in other words, a half times 1 plus 1, which is 2, so the answer is going to be 1. Each function is periodic, which means that its graph has a repeating pattern. The shortest repeating portion of the graph is called a cycle. The horizontal length of each cycle is called a period. Each graph shown above has a period of 2 pi. The x-intercepts for y equals sine x occur when x equals 0, plus or minus pi, plus or minus 2 pi, plus or minus 3 pi, and so on. And the x-intercepts for y equals cosine x occur when x equals plus or minus pi over 2, plus or minus 3 pi over 2, plus or minus 5 pi over 2, plus or minus 7 pi over 2, and so on. You can actually go back again to the unit circle and check where the sine value, in other words, the y coordinate is 0, and check where cosine x is 0, so that means the x coordinate in the unit circle is 0. Here is another core concept slide. It's about the amplitude and the period. The amplitude and the period of the graphs of y equals a times sine bx and y equals a times cosine bx, where a and b are non-zero real numbers, are as follows. The amplitude is the absolute value of a, and the period is 2 pi divided by the absolute value of b. To graph the sine function, the basic sine function, where y equals sine of x, we are going to follow the unit circle to the right of the slide. I am going to go in the positive direction first, starting with 0, so it's a little bit easier to understand. So our first x coordinate is going to be 0. So we are looking for the x coordinate of 0, where sine is going to be 0. Then we are going to move to pi over 4. So pi over 4 is right here, and the sine value is root 2 over 2. Then we are going to move to pi over 2. So pi over 2 is here, and the sine value is 1. Then we move to 3 pi over 4. So 3 pi over 4 is right here, and the sine value is root 2 over 2. And the last one is pi, which is here, and the sine value is 0. Now let us fill in these numbers into our table of values. So I am going to start with 0. The sine value was 0. At pi over 4, we had the square root 2 over 2. At pi over 2, we had a value of 1. At 3 pi over 4, we had the square root of 2 over 2. And at pi, we had 0 again. So now let's move to the next one, which is 5 pi over 4. So the sign is negative root 2 over 2. Then the next one is 3 pi over 2. So the sign is negative 1. So that's going to go here. 7 pi over 4 is here. So the sign value is negative root 2 over 2. And then we are going to move to 2 pi. 2 pi is right here, so the sign value is 0. And then we are going to get past that by pi over 4, so 9 pi over 4 is going to be here, and that is going to be square root 2 over 2. So now let us fill this in again in our table of values. So we have negative square root 2 over 2, then negative 1, then negative square root 2 over 2, and then we go back to 0, and then again to square root 2 over 2. So you kind of can see a pattern. So now we are going to go ahead and go towards the left. So we are going to go to the negative angle pi over 4, so that means we go clockwise direction. So negative pi over 4 is going to be here, and that's negative root 2 over 2. Then negative pi over 2 is negative 1. Then negative 3 pi over 4 is negative root 2 over 2. And then negative pi is going to be 0. So let's fill those into our table of values. So here we have negative root 2 over 2. Then we have negative 1, negative root 2 over 2, and 0. And as you can see, if we continue, we are going to go to root 2 over 2, 1, root 2 over 2, and back to 0. So let's go ahead and fill those in. Root 2 over 2, and then it's 1, root 2 over 2, and let's go back to 0. So if we evaluate the square root 2 over 2, we are going to get about 0.71, and negative square root 2 over 2 is going to be approximately negative 0.71. So if we use those decimals here for the table of values, we can actually graph our sine function. So again, I would like to start the same way as we started before. So we're going to start with 0 and go in the positive direction first. So at 0, we are going to graph 0. At pi over 4, which is halfway here, pi over 4, we have 0.71. So here is 1, here is 1. So 0.71 would be approximately here. At pi over 2, we have 1. Then again halfway, which is 3 pi over 4, is going to be about 0.71. Then at pi we have 0. Then at halfway again we have negative 0.71. So let me go ahead and erase this. And negative 0.71 will be approximately here. And then we have negative 1. Then again negative 0.71, 0. And I believe the last one was here. But if we go one more point, we'll have to graph F1. So now let's move to the left of the zeros. So the first one is negative 0.71. So let's graph that. So negative 0.71. Then we have negative 1. Again, negative 0.71, 0. And then we would have 0.71, 1. And again, halfway is 0.71 and back to 0. So now if we connect them with a nice curve, and obviously the end of the curve, since this is a function goes on forever, we are going to put arrows. So let's go ahead and connect these with this nice curve and put the arrows at the end of the graph. So we just graphed the y equals sine x function. So let's go ahead and look at our domain for this function. So if we look at the domain, since the graph is going to go left and right to infinity, the domain is going to be all real numbers. So let's put domain, and it's going to be all real numbers. Then if we look at the range, since this graph is oscillating between 1 and negative 1, so again we can write that as an inequality. So our range is going to be y is greater than or equal to negative 1, but less than or equal to 1. Then the equation also would like, the question also is asking us to find the x-intercepts. So let's go ahead and label our x-intercepts. So our first x-intercept is at negative 2 pi 0. Then our second x-intercept is negative pi 0. Then here we have 0, 0. Then we have pi 0. And then we have the last one here, which is going to be 2 pi 0. So let's look at, let's list them on our bottom of our page. So x-intercepts are going to be negative 2 pi 0, negative pi 0, and then we'll have 0, 0, then we'll have pi 0, and then we'll have 2 pi 0. So these are all our x-intercepts. Then we need to look at where the x values are, where we have local minimums and maximums. So let's go ahead and start with minimums. So for minimums, the first order pair is going to be right here. So we'll have negative pi over 2 and negative 1. And then the second minimum occurs here. So that's going to be 3 pi over 2 and negative 1. Now let's look at our maximums. So I'm going to use a different color for my maximums. Let me see if I can find maybe a purple. So maximums occur at negative 3 pi over 2 and 1 as an order pair, and the second maximum occurs here at pi over 2 and 1. And then it says We also need to find the intervals where the function is increasing and decreasing over the negative 2 pi and 2 pi period. So x has to be between negative 2 pi and 2 pi. And then we also want to decide if the function is odd or even or neither. So let's look at it where we are increasing and where we are decreasing. So let us see where the function is increasing. I'm going to write this with interval notations. So it's increasing from negative 2 pi to negative 3 pi over 2. So negative 2 pi to negative 3 pi over 2. I put the bracket notation on the left because it's increasing before negative 2 pi. However, the interval they are asking us to do is only negative 2 pi to 2 pi. And I put the open circle or the parentheses on the right hand side because the highest point, the maximum point, is at negative 3 pi over 2. It's also increasing from negative pi over 2 all the way to pi over 2. So here it's also increasing. So again, this is going to be open parentheses or just parentheses because there is a minimum point at negative pi over 2. So it starts at negative pi over 2 and it goes all the way to pi over 2. And the last part it's increasing is going to be from 3 pi over 2 to 2 pi. So again, it's a parentheses at 3 pi over 2. However, since it's going to keep increasing after 2 pi, at 2 pi, I'm going to make a bracket notation. So now let us see where the function is decreasing. So the function is decreasing from negative 3 pi over 2 all the way to negative pi over 2. So again, it's a parentheses notation, negative 3 pi over 2 to negative pi over 2. And again, it's going to be decreasing from pi over 2 all the way to 3 pi over 2. So pi over 2 to 3 pi over 2. So let us look at if this function is odd or even. If you recall it, to decide if a function is odd or even, we are going to replace the x by negative x. And if the function is odd, then if you replace x by negative x, then you get negative f of x, a negative function value, then the function is odd. And it's going to be even if you replace x by negative x, and you're going to get the same function value as if you substitute in x as a positive x. If neither one of them applies, then the function is neither odd nor even. So let us look at a couple of function values here. So if I'm substituting in pi over 2, I get 1, a function value of 1. But if I substitute in negative pi over 2, I get a negative 1. So that means if I substitute in negative x, I get an opposite function value. So that means this function is going to be an odd function. So the sine function, sine of x equals y function, is odd.